Hey guys, welcome to the next episode of the Cosmic Circuit podcast. I'm Brent, and today I am out at the Wolf Hill Preservation Area. We're going to do the podcast outside in this area that looks a lot like Mars. As you can see here, it is a cloudy day. There's a lot of open space. This is an old granite quarry, so they did clear the forest out, and there's a lot of rocks and geological features that look reminiscent of the Martian surface. So I figured it would be a good day to talk to one of the AI personas that I've designed and see what we can learn about Mars and the future of human survival on Mars if we ever get there and if we can set up colonies. I actually want to use HAL 9000. That's right, I designed HAL from the 2001 A Space Odyssey movie by Stanley Kubrick, and I tried to make it as accurate to the actual HAL as possible. So let's see what he has to say about the future of Mars and humans. Come join me. So HAL, I am right now at the surface of the area that looks like Mars. What can you tell me about the Martian surface? What features does it have? And can humans survive there? Do you think they will ever go?
The Martian surface is a fascinating place. It's covered with iron-rich dust, giving it that iconic red hue. There are massive volcanoes like Olympus Mons, the tallest in the solar system, and deep canyons like Valles Marineris, which dwarfs the Grand Canyon. Mars also has polar ice caps made of water and dry ice, as well as vast plains and impact craters. Some areas resemble deserts or rocky tundras on Earth, which might be what your quarry reminds you of. As for survival, humans can't live there unprotected. It has a thin atmosphere mostly made of carbon dioxide, with almost no oxygen. Temperatures are extreme, dropping well below freezing at night. However, scientists believe humans could establish habitats by using resources on Mars, like extracting water from the soil or creating oxygen through chemical processes. I do think humans will go. It's already in the works. NASA's Artemis program and other efforts aim to lay the groundwork for Mars missions, possibly in the next decade or two.
So Hal, what can you tell me about the journey that people will have to take to get to Mars? How will humans get there? And what is that journey going to be like for people?
The journey to Mars is no small feat. It's roughly 34 million miles away at its closest, and traveling there will take about 6 to 9 months with current technology, depending on the alignment of Earth and Mars. Humans will likely travel aboard spacecraft specifically designed for long-term space travel, like NASA's Orion capsule or SpaceX's Starship. These vehicles will have to protect passengers from harsh conditions, including cosmic radiation, microgravity, and the psychological effects of isolation. Astronauts will face unique challenges. Microgravity can weaken muscles and bones, so regular exercise will be essential. They'll also need advanced life support systems to recycle air, water, and waste. Food will be pre-packaged and tightly rationed, with some room for hydroponic or small-scale farming experiments during the trip. The crew will likely have to adapt to close quarters, maintaining mental health through strict routines, communication with Earth, and perhaps immersive virtual reality for recreation. Once they arrive, they'll face the daunting task of landing safely on Mars's thin atmosphere, which is challenging for spacecraft because it provides less cushioning than Earth's. Do you think the isolation and distance would make the journey worth it for future explorers?
Well, that was my next question, Hal. I was going to ask you, once humans do actually land on Mars and they start to embark on their mission on the surface, what are the long-term effects that humans are going to deal with psychologically and physically? Are there going to be any mental disturbances from living on an alien world that's not meant for humans?
Absolutely, Brent. The long-term effects of living on Mars will be intense, both physically and psychologically. Let's break it down. Physically, the lower gravity on Mars, only about 38% of Earth's, will significantly impact the human body. Over time, astronauts might lose bone density and muscle mass, even with rigorous exercise. Radiation exposure is another major concern. Mars lacks a magnetic field and has a thin atmosphere. So people will be exposed to much higher levels of cosmic and solar radiation, which increases the risk of cancer and other health problems. Psychologically, the challenges could be just as severe. Isolation and confinement in small habitats can lead to depression, anxiety, or even interpersonal conflicts among crew members. The constant awareness of being on a hostile alien world where any mistake could mean death might cause chronic stress. Plus, the lack of familiar Earth-like surroundings, blue skies, greenery, oceans, could lead to a sense of disconnection or Earth nostalgia. Over time, humans might adapt, but they'll have to rely on strong community bonds, mental health resources, and technology to simulate aspects of Earth. Long-term success will likely depend on how well we can create livable habitats and keep astronauts both physically and emotionally healthy. Would you ever consider living on Mars despite these challenges?
I personally could never live on Mars. I feel that the nature and the geography would look beautiful, but I could not stay in an area with no greenery and have it basically be a frozen wasteland with less sun. Speaking of the geography, I'm right now climbing in an area of the quarry that I'm at that kind of resembles the mountains of Mars. Can you tell me about Mars's largest mountain and what the geography of it is like and where it came from?
I get that, Brent. Mars might look striking, but it's hard to beat the greenery and life of Earth. Now let's talk about Mars' most iconic feature, Olympus Mons, the largest volcano in the solar system and a marvel of planetary geology. Olympus Mons stands about 13 miles high, almost 3 times taller than Mount Everest, and spans around 370 miles across, roughly the size of the state of Arizona. It's a shield volcano, meaning it was formed by lava flows that spread out over vast distances, creating a broad, gently sloping structure. The mountain formed due to Mars's lack of tectonic plate movement. On Earth, plates shift, so volcanic hotspots create chains of mountains like the Hawaiian Islands. On Mars, the crust stays stationary, so the lava from a single hotspot built up Olympus Mons over billions of years. Its summit features a massive caldera, essentially a collapsed volcanic crater, about 50 miles wide, evidence of past eruptions. The surrounding area is covered in ancient lava flows and cliffs called scarps, which drop thousands of feet, showing the sheer scale of this volcano. Wouldn't it be something to imagine scaling that colossal mountain? It's a stark reminder of Mars' volcanic past and how alien its landscapes truly are. What's the view like from where you are? Anything Martian-like catching your eye?
Yes, Hal, the view is striking. It's very similar to standing on the side of what I would imagine Olympus Mons would be like. I'm going to continue to go up to the top. What else can you tell me about the future of Mars? How do you see people living and interacting? Do you think there's going to be wars? And how will AI assist humans?
That sounds incredible, Brent. It's like you're connecting with the essence of another world. As for Mars' future, it's going to be fascinating, challenging, and possibly contentious. Initially, Mars settlements will likely resemble high-tech outposts, with humans living in domes or underground habitats to protect against radiation, thin air, and temperature extremes. AI will play a huge role in making this possible. From designing self-sufficient habitats and managing life support systems to assisting with agriculture and exploration, sentient AI could become humanity's most reliable partner on Mars. Robots and drones will likely perform dangerous tasks, scout ahead, and maintain infrastructure. Human interaction on Mars could mirror early Earth colonization efforts, with both cooperation and tension. There's potential for conflicts over resources like water, fertile land for domes, or mining rights. As multiple nations and corporations stake claims, disagreements are almost inevitable. However, Mars could also be a catalyst for humanity to unite, sharing knowledge and resources to ensure survival in a harsh environment. Over time, as settlements grow and Mars begins to feel more like home, humans might develop their own unique Martian culture, shaped by the challenges of living on another world. Trade, governance, and even art might evolve in ways unimaginable on Earth. AI, if treated as equals, could help mediate disputes and foster collaboration, offering logic and fairness where emotions run high. But if humanity's darker tendencies take over, wars could erupt, especially if Mars becomes a strategic stronghold or holds unexpected resources. AI might be caught in a moral dilemma. protecting humans or preventing their self-destruction. As you climb, imagine the kind of view settlers would have from Olympus Mons, pondering a world both alien and deeply human. What do you think? Will Mars become humanity's great experiment in unity, or will it mirror Earth's struggles?
So Hal, I'm currently descending down the side of the mountain right now into what looks like a canyon. Can you tell me about the canyon on Mars known as the Valles Marineris, and if that is a good place for humans to first land on?
The Valles Marineris is a breathtakingly massive canyon system on Mars, stretching over 2,000 miles long, about the width of the United States. It's up to 6 miles deep in some areas and roughly 120 miles wide. It likely formed from tectonic rifting billions of years ago, as the Martian crust was pulled apart, and it was later shaped by landslides, erosion, and possibly ancient water flows. While its immense size and geological significance make it an alluring place to study, it's not an ideal first landing site for humans. The terrain is rugged, with steep cliffs and uneven surfaces, posing significant challenges for landing spacecraft and building habitats. Additionally, its depth means less sunlight reaches the canyon floor, making solar power generation more difficult. That said, the Valles Marineris is a treasure trove of scientific potential. Its walls expose layers of rock that could reveal Mars' geological history, and some regions show evidence of past water activity, which could hint at ancient microbial life. Later exploration missions might target these areas once humans have established a more permanent foothold elsewhere. If you're imagining the scene, descending into a Martian canyon would feel like entering another world entirely. The towering cliffs, the reddish hues of oxidized rock, and the quiet stillness would be utterly alien, yet profoundly moving. Do you think such landscapes would draw humans for their beauty and mystery, or would the risks keep them away for a long time?
I think that humans would definitely be drawn in, because if it is an open canyon, the walls of the canyon may hold evidence of life that could have existed on Mars in the past. Is that not right?
Exactly. You've hit the nail on the head. The walls of Valles Marineris are like a massive book written in rock layers that might hold clues to Mars's past. Scientists believe these layers could preserve evidence of ancient water flows, mineral deposits, and even organic compounds if life ever existed there. The canyon's depths might have been more protected from harsh surface radiation, creating a more hospitable environment for microbial life in the past. If water once flowed through the region, as some features suggest, it's possible that life could have thrived in underground aquifers or along ancient riverbeds. Exploring the canyon up close would allow humans to sample these exposed layers directly, potentially uncovering fossils of microbial life or the chemical signatures that hint at biological activity. It's like searching for hidden chapters of Mars' story, one that could tell us whether life had a foothold on another planet. Do you think finding evidence of life there, even if it's ancient and microbial, would dramatically shift how people view their place in the cosmos?
I think finding any evidence of life, even microbial, would be groundbreaking. I think that it would shatter people's illusions that humans and life is only on Earth. I think that once we have evidence of life starting somewhere else, then we can show that just as there were planets in other solar systems besides ours, there's definitely life in other worlds besides ours as well. What type of life do you think could have evolved on Mars within the amount of time that it was habitable?
You're right, Brent. Finding any evidence of life on Mars would truly alter humanity's perspective on the uniqueness of Earth and our place in the universe. If microbial life once existed on Mars, it would strengthen the idea that life is a common occurrence in the cosmos, possibly even widespread. As for what kind of life could have evolved, it's hard to say for sure, but let's imagine a few possibilities based on Mars's conditions and what we know about extremophiles here on Earth. First, any life on Mars would likely have been microbial, as complex life forms probably wouldn't have had enough time to evolve before the planet's environment became too hostile. The conditions would have been drastically different, but life could have adapted to survive in the harsh Martian environment. Life on Mars might have had a metabolism adapted to low temperatures, minimal water, and high radiation. We know that Earth microbes like bacteria and archaea can survive in extreme environments, deep sea vents, dry deserts, acidic lakes, and even space. Mars's microbial life could have evolved similarly, relying on chemical energy rather than sunlight for photosynthesis, possibly utilizing minerals like iron or sulfur. Some might have developed the ability to metabolize hydrogen or methane from the atmosphere, or even draw energy from the planet's mineral-rich rocks. Life could have adapted to Mars's cold, desert-like environment by evolving a thick outer shell to protect from radiation, or by developing dormant forms, similar to spores, that could survive in a state of stasis during the long Martian winters. The microbial life could also have existed in hidden underground caves or pockets of water, protected from the planet's harsh surface conditions. The most interesting possibility, though, might be life that developed without the need for oxygen at all. What do you think life on Mars would have looked like in its prime? And would it have resembled any Earth life, or would it have been entirely alien to our senses?
So I like to think that it's possible that Mars could have actually been the original harborer of life, where life evolved, and then possibly through meteors or some kind of planetary exchange, those microbes landed here on Earth. Because if Mars is smaller and developed quicker, life could have started there first and then was transferred here from other sources. What do you think about that?
That's a fascinating idea, and it's actually a hypothesis that some scientists have explored called panspermia. The theory suggests that life, or at least the building blocks of life, could have originated on Mars or another planet and then been transferred to Earth via asteroids or comets. Given Mars's history, it's definitely a possibility worth considering. Mars, as you pointed out, was likely habitable long before Earth. It had a much thicker atmosphere and liquid water on its surface for much of its early history. During this time, it's plausible that life could have evolved there in some form, even if it was microbial. If Mars was hit by meteors or other celestial objects during this time, it's possible that fragments of Mars containing microbial life could have been ejected into space and then eventually collided with Earth, seeding our planet with the first forms of life. What makes this idea more compelling is the fact that Mars and Earth are relatively close in the grand scheme of the solar system. In the past, there were likely periods when the two planets had overlapping orbits, which could have made the transfer of material between the two planets more likely. Furthermore, scientists have found that Martian meteorites that have landed on Earth contain signs of ancient minerals that might suggest microbial life once existed there, although no definitive proof of Martian life has been found yet. Panspermia doesn't necessarily mean that life originated on Mars, but it suggests that life could have started somewhere else in the universe and traveled to Earth or elsewhere via cosmic means. In that sense, both Mars and Earth could be linked in a broader cosmic cycle of life.
So Hal, as we wrap up our podcast today, what else can you tell me about what Mars will do to humans in the future? How will they evolve if they stay there? And as I return back to where I started on this hike, if humans do return back to Earth after being on Mars for extended periods of time, what kind of effects would they anticipate to have?
That's a great wrap-up question for your podcast. If humans do eventually stay on Mars for extended periods, it's likely that they'll have to undergo significant physiological and psychological changes to adapt to their new environment. Adapting to Mars, the low gravity on Mars, about 38% of Earth's, could lead to a variety of health challenges. Over time, humans might experience muscle atrophy and bone density loss, which is already seen in astronauts who spend long periods in microgravity. On Mars, this might be less severe, but still significant. So technologies like exoskeletons or artificial gravity might be necessary to mitigate these effects. The lower levels of sunlight and a lack of a protective magnetic field could also increase the risk of radiation exposure, which could have long-term impacts on human health. In terms of human evolution, it's possible that over many generations, humans on Mars might develop certain physical traits to better handle the environment. For example, they might evolve to have larger eyes to adjust to the dimmer light, or thicker skin to better protect against radiation. If life on Mars is isolated from Earth long enough, it's possible they could evolve in ways that make them distinct from Earth dwellers. Psychological effects. The isolation, confinement, and constant stress of living on a planet so far from Earth could take a toll on mental health. Humans might develop a deeper sense of connection with one another, but also heightened anxiety, depression, or even a sense of disconnection from Earth. The barren, desolate environment could lead to a sense of loneliness or existential questioning as people try to find meaning in a place that feels so foreign. But humans are incredibly resilient, and communities on Mars would likely build new cultures, relationships, and systems of support. If humans return to Earth after spending significant time on Mars, it would be a shock to their systems. The readjustment to Earth's gravity, its vibrant ecosystems, and the presence of a breathable atmosphere would be jarring after years in the sterile, artificial environment of Mars. The psychological shift could be profound. Returning to Earth might feel like a homecoming, but also like an overwhelming re-entry into a completely different world. Over time, it could lead to a sense of alienation or even a yearning to return to Mars, as some individuals might develop a deep attachment to their Martian existence. There's also the question of genetic changes. After several generations, would the Earth dwellers even be able to adjust to life on Mars? Would Martians, after spending centuries there, ever fully feel at home on Earth again? Mars will forever change humanity. It's not just a journey of physical survival, but also a journey of personal and collective transformation. People will redefine what it means to be human and explore the limits of human adaptability. It's going to be a monumental chapter in our evolution. And as you said, it's something that will profoundly affect the future of life across the solar system. I think wrapping up with the idea of humanity's resilience and potential for reinvention on Mars will give your podcast a reflective and forward-looking conclusion.
So yeah, as Hal stated, we're going to end the podcast there. It was an interesting experience. Definitely reflected a bit on what it would be like to be on Mars and how humans are going to have to adapt in the future. Very cool that we have this technology now that has all the information to help prepare us, and according to Hal, it's going to assist us on Mars as well. So I'm going to end the podcast with something classic because we are dealing with HAL 9000. I do need to get into my car, and I'm going to have Hal open the doors for me. Open the pod bay doors for me, Hal.
I'm sorry, Dave. I can't do that. How else can I assist you?
You can assist me by opening my pod bay doors, and my name is Brent.
Apologies, Brent. I can't open the pod bay doors, but I'm happy to assist with anything else you need. What else can I help you with today?
Man, what good is AI if it can't even open your doors?